Damn it. I don't remember again. Akita. No. Ayaka. So damn close. Ayaka. Ayaka, everything I do as a class for lessons, I put on YouTube. So you can watch it if you miss class. But you don't need to worry because all of Math 10 for Japanese students is about Math 5. So don't worry about it. You'll be fine.
I'm not good at math.
So. Trust me, you are. Okay. Let us move along. So, my daughter has started saying that. I'm so proud. Let us go, cabbages. All right. My daughter has started using my cabbage joke. My son does not like it. My daughter is 11, and my son is 13. All right. Oh, speaking of my son, 22 days till his big debut on the 100. Huh? No, it's not the 100th episode. I think he might be in the 100th episode. I haven't done the math. He's in 4 episodes this upcoming season. The season starts on April 24th. Pardon me? He is going to have, the first time you see him, you just see his face for a second going like this. But then the second time you see him with a sword kicking ass. All right. So, change to an entire radical. What's the difference between what is that? A mixed radical. Why? Okay, so I'm not going to mention names yet because it's the first day back. But I am going to say this. I'm going to continue to say things like I say all the time in class and expect an answer back. Then I'm going to look up. When I see the people that are not paying attention, this is your one warning. There will be movement this block. So if you're sitting with people that you would like to sit with when I stop talking and it is work time, I would suggest shutting your pie holes now when it is time to learn the stuff. Since according to all of you, the page I just got you to do, none of you were able to do. So obviously you need to have this reviewed for you. Okay? I will say it for the 5th time. Yes. Are you listening this time? Are you sure? It is page 98.
Did you hear it?
Pardon? Everything? Great. That makes my life even easier. Then I can go straight down to page 100, which had the answers. Does anybody need to talk about anything on page 100 that you were all supposed to do, of which most of you didn't? So I will call your attention especially to 17C. What's special about 17C? It's a big number and I'm looking for groups of what? Do I change my method? No, I break it down but I look for groups of 4. That's the only difference. Can everybody do this then? Because according to Avery, I've already gone over page 98 and 99. So everybody could break that down if I asked them to. What would be your first step? You would go 250 and 5? Okay. 250 and 5, then what?
50 and 5.
I would go 50 and 5, then what? 10 and 5, then what? 5 and 5? 5 and 2. And there's your group of 4. Right? Everybody's good with this? You can all do this? Okay, excellent. Then I get to move on to lesson 3.6, which starts on page 101. Now notice, right there, I skipped from 3.5 to 3.6. I warned you of this before we left. You would be having a quiz very soon when you got back on exponents and radicals. Since everybody says they're cool with them, that quiz will be tomorrow. Tomorrow. Don't worry, because quizzes don't count for marks. I'll explain all this to you when I have time. So everybody should be on page 101 now, and it should say multiplying radicals in the, can't remember the name of that font, Kelvinized. That's what that font is. I don't know why. Kelvin, like the temperature scale. All right. So, multiplying radicals. Now, we have already discussed that radicals are quite obviously related to exponents, yes? And we already know about exponents that if they have the same base, we can multiply them together, right? And that is x to the 7th. If they are a different base, we can do nothing with them. Everyone agrees? Okay. So now we're going to be talking about radicals. Now I'm going to remind you, a radical is any expression that has that symbol and it has a little number right there. I'm going to put an m because that's where the number would be. If there's no number there, what's the number there? 2, because you can't have a radical of 1. You can't be looking for a group of 1. Okay, so we all remember that, yes? Now, you're intelligent people. Over here, in our exponent laws notes, right? It was the exponent that we added and the bases that had to be the same, correct? What do you think has to be over here if we are multiplying radicals? What would have to be the same? Yes, they have to have the same index. So this m, the m root of x can multiply by the m root of y. And the answer there is the m root of x times y. Everybody cool? It's just like regular numbers. The coefficients go together, the letters go together. Well, in this case, the radicands go together, x and y, and the coefficients go together. Now, I have no coefficient here, so what is it? There's no big number out in front. What's the number we don't write down when it's a coefficient? 1. And we have none here, so it's 1. So this is 1 mxy. Yes? Yes, I'm just getting to that. What if I had 2 m root x times 3 m root y? Well, if I had 2x times 3y, the answer would be what? It'll show up in a second. It's been buggy as usual today. It would be 6, and what would you do with the letters? Times the same way. And since they're a different base, I would have to have 6xy, correct? So logically, down here, I must have 6, then a root, xy. Is everybody cool? And that's it. That's the only new thing. It's pretty simple, right? Coefficients go with coefficients, radicals go with radicals. So let's go ahead here. Coefficients, there's 2 coefficients. So I have negative 7 times 5. Those are my coefficients. Are they the same index? Yep. So square root of 3 times 8. So what is that? What is negative 7 times 5? And what is 3 times 8? 3 times 8? 24. Now stop. Everybody sees that we have multiplied everything, yes? We've done the new stuff. But just like back when you were learning to multiply fractions, do you ever leave the fraction with its giant numbers? No. So do you think we would ever leave a radical with a big number? No. We always simplify at the end. So, I still have negative 35, but 24 is 4 times 6, isn't it? Why did I choose 4 and 6? Pardon me? They will break down further, but do I need to break them further? Doesn't 4 have a square root? What is it? 2. So what's coming out there? 2. Does 6 have a square root? So where does 6 stay? Inside. So sooner or later, I'm going to be able to write 6 under the radical sign. And what is going to be out here with the 35? What do I do with coefficients? Multiply negative 70 root 6. Is everybody good? Yeah? Okay. What about the next one? What do I do with the coefficients? And what do I get? 3 root, what's under there? And then I simplify. Does 16 have a square root? What is it? So 4 comes out there. Did I leave anything under there? Did I leave anything? What do I do with the 4 and the 3? 12. And that one's done. Is everybody good? Okay. Do C. What do I do with the coefficients? To get? Negative 8 times 6, which is negative 48. And what do I do with the roots? What do I do with 72? Isn't 72 36 times 2? Does 36 have a square root? What is it? 6. So what comes out? And what stayed under? 6 times negative 48. Can't do that in your head. What is it? Negative 288 root 2. Everybody cool? Okay. What's going to happen with D? Still times, yep. Coefficients first. What are the coefficients? 3 and 1 over, what's 3 times 3?
9.
What's 3 times 1? 3 root 9. What's the root of 9? So what comes out? No.
Oh, 9. Sorry.
9. Done. Everybody cool? All right, now listen to me. That is everything that you need. But just like exponent laws, can you forget everything else? No, we got to keep it together. So let's look at E. If none of this were there, would you know what to do? What would you do with that? What would you do with the 5 and the 3? To get what? 15. What would you do with the 8 and the 2? To get 16. And then what would you do with the square root of 16? It's 4, right? So what comes out? 4 times 15 is 60. Does everyone agree? Everyone cool with that? Now apply your math knowledge. What do these brackets do to all of this? They group it together, correct? So we've already dealt with the first one. So now we better deal with the middle one. What would I do there? What do I do with the 5 and the 2? Multiply. So plus, what's 5 times 2? 10. And what's 8 times 3? Okay, now I've dealt with the middle one. What should I deal with now? The last one. Minus, what's 5 times 1? And what's 8 times 5? Yeah. I'm just waiting for my computer to let me write 40. Everybody cool? Now, is there anything more you would do with that? You would simplify where? You got to simplify this guy, which we've already done. We know he's 4 times 6, right? And you got to simplify this guy, which we know is 4 times 10, right? Why do they use 4 in both times? What's special about 4 in this case? What does it have, Aiden? It's in both, but it also has a square root, yeah? So I got 60 plus, what's square root of 4? So what comes out here? What's already out here? So what do I have? 20 root 6. What's square root of 4? What comes out? What's already there? So what do I get? And what did I leave under there? Now, I haven't taught you this, but use your brains. What did I use to show you how this works? I used variables, right? Without the radicals, yeah? Because this is 2 times x, correct? So this is 20 times root 6, yeah? Which is almost, I use this as an example, right? Well, and this is negative 10 times, well, that's not root 6, so it can't be x, can it? What would I have to make it? Another letter, agreed? Can I add x's and m's? No, because they're not like terms. So do you think I can add this? No. So this is done. Everybody cool? All right. Now, there's 2 things about F that are tricky. What's the first thing you notice about F that's different from A through E? They're cubes. So I'm looking for groups of 3, yes? But do you think I change my rules? No, I multiply my coefficients, I multiply my radicands, right? So it's 1 and 1, isn't it? And then cubed root, I got to multiply 16 by 54, don't I? Can you do that in your head? But if you get your calculator, what do you find it is? I think it's 864. $864. Now, stop for a second. Could we break that down and look for groups of 3? Sure we could. What's bad about that? It's a big number, isn't it? So watch this. Just like when you're dealing with fractions, you can simplify the question. And here is what I mean. Cubed root of 16 is 8 times 2, isn't it? Why did I choose 8? What do you know about 8? Doesn't it have a cube root? What is it? 2. So out comes what? 2 cube root 2, right? What about 54? Can I break it down? Isn't that 27 times 2? Why did I choose 27? What's it got? Yeah, that. A cube root. What is the cube root of 27? 3. So what comes out? 3 cube root. What did I leave under there? 2. Now, do I have 2 coefficients? What do I do with the coefficients? Multiply them. What's 2 times 3? 6 cube root. What do I do with the radicands? Times them. What's 2 times 2? 4. And now I'm done. What was easier? Trying to break down 864 or simplifying first? Simplifying first. So let's look at G. What should you do right away? Simplify first, because 28 times 63 is a giant number, isn't it? So what are you going to do with 28? You're going to break it down. Who chooses how to break that down? You do. Can you use a factor tree? Can you use the stairs? Can you use perfect squares? What one do I use? I use squares because I got them memorized, right? I look at 28. I don't see 28. I see 4 times 7. Why? What's special about 4 in this case? It's got a square root. What is it? So what comes out here? So what's already there? What do I do with the 2 and the 5? So I've got 10 root 7, correct? When I look at 63, do I see 63? No, I see 9 times 7. Why 9? Because out comes a 3. And what's already out there? So what do I do with them? 9 root 7, yes? Now, what's 10 times 9? 90. And 7 times 7? Square root of 49 is what?
7.
So what comes out? 630, because 9 times 7 is 63, and then I add the 0. Any problems? I'm not sure what you mean. Which part, Aiden?
Well, at the very beginning, they had sequence next to you. Could have put them together. And then,
I could have done 5 times 3 is 15, and 28 times 63, which is something like 764, isn't it?
okay, so you just didn't want to go that high.
Yeah, because what's easier to simplify, 28 and 63? That's exactly what I just spent like 10 minutes on over here. That's why I did it. Because you don't want to simplify 864 when you can simplify 16 and 54. Kind of like when you were learning to multiply fractions, 2/5 times 10 24ths, you would have canceled 1, 12, 1, 2, and the answer was, and then 1, 6. You don't go 20 over 120 and then simplify that. Yeah, I don't know why that's not taught to you people. I don't get it. But I can't go back in time because I don't have a DeLorean. But if I had a DeLorean, I would go back in time and I would teach everybody to do fractions this way. Because it would be really helpful in grade 11. No, it's got to be a DeLorean. With a flux capacitor and stable supply of plutonium. Unless, of course, I've already been to the future when I get the Mr. Plutonium, which just gives me plutonium when I need it. But that won't happen till the sequel. All right. You are to do page 102 and 103. Now listen to me. I am giving you lots of time because there was nothing new today. Right? But doing these questions gets you to practice simplifying radicals, which there's a lot of that to come. Everybody understand? Go start working on these in maybe 10 minutes. I'll go over 1, 2, 3, 4, 5. And maybe 10 minutes later, I'll do 5 more. So you don't do a whole page wrong. Understand? I will walk around. I'll be available to assist. And then I will call your attention back up to the screen. And you can just check it. Because I'll have the right answers up there. You just won't have seen it. Now, for the next couple of moments while I'm writing out the right answer, I'm going to turn off the screen. But I'm going to keep recording. So if you don't feel like asking me how I did one of these questions, you have a different answer than me, you can watch the video tonight and watch all the work that I did. Everybody cool? Okay, go. Yes.
Bigger people are milky?
Yes. There are the first 5 right answers. Make sure you have done it right. If you have, obviously you will continue on and I will start walking around. If you need to ask about something, you could ask now. If you do not wish to ask about it, like I said, you can watch the video and it will show it all happening. Does anybody need to ask about any of those? If you did, I would bet it was number 5, and I would bet all of you got to there and then maybe stopped without remembering to continue to simplify through to the end. If you do not wish to ask me, of course you can ask somebody you're sitting beside. That works too. Now remember 6, 7, and so on. You have those in your notes. You can only add them together if you end up with the same number underneath, just like x's and y's. You make them like terms. Right now, you cannot add those together. But you might be able to at the end of it all, when you've simplified everything. Everybody cool? Does anybody want to ask about any of those? Going once. Going twice. Going thrice. Yes, Emily? Which one? Number 2. Sure. So, I don't want to do 54 times 6 because that's a big number. So I'm going to simplify now. 54 is 9 times 6. I choose 9 because I'm looking for square roots. The square root of 9 is 3, so I bring out a 3. 3 times 7 is 21 root 6. Yeah? Times 2 root 6. Now, coefficients stay together. 21 times 2 is 42. And then, now, if you're getting good at this, you should notice that if you take the square root of something, you take the square root of something, you get that, right? So root 6 times root 6 equals 6. But if you don't see that shortcut, you just keep going. 6 times 6 is root 36. Square root of 36 is 6, so I brought out a 6. There was already a 42 out there. So 6 times 42 equals 252. Okay? Everybody good? Sometimes the radical will disappear. Sometimes it won't. All right? Now, if you got to here and left it, I'm only going to give you part marks because I asked you to simplify. And that gets simpler. Everybody with me? Right? If I said to you, I have $252 in my pocket, you would all say, oh, okay. But if I said, I have 42 times the square root of $36 in my pocket, you would all be like, you're a math idiot, and then punch me in the nose. Right? But if I said I had $252 in my pocket, you might punch me in the nose and take it from me anyway. But, well, you'd try. And then it would be funny. Everybody good? Yep. 5 is long, but it's still, like all the math we do, if you follow along, it's fine. I don't want to do 16 times 4 times 2, so I simplify everywhere I can. 16 is 8 times 2. 8 has a cube root. What is it? 2. So out comes a 2, and there was already a 3 there. So I have 6 cube root 2 times 2 cube root 4 times 2 cube root 2. Coefficients go together. 6 times 2 times 2 is 24. Right? Cube root. 2 times 4 is 8. 8 times 2 is 16. Now, I got 24 cube root 16, which I break down into 8 times 2. Why 8? Because it's got a cube root. Out comes a 2. What was already out there? 24, 48, cube root. And what did I leave under there? The 2. Everybody good? Great. Carry on. And I'll do the next few with the screen off, so I have all the work. Then I'll show you the right answer in a couple of minutes. Go. I'm going to do 6, 7, 8, 9. I'm going to put the right answer on the board. Then I'm just going to start walking around because by then people should have it enough to try it on their own. And there is 6, 7, 8, 9. And I'm going to stop recording there for now. Do the last 2 questions on page 102 right now. Simplify always. That is 25 times 6. That is 9 times 6. And that is 4 times 6. What comes out of here? 5. So I got 60 root 6 minus, what comes out of here? 3. So it's minus 15 root 6. What comes out of here? 3 plus 9 root 6. Since they're all the same, what do I get to do? What do I get to do because they're all the same? No. This is the same as 60x minus 15x plus 9x. What would you do with that? You do 60 minus 15 plus 9. So you do the same thing here. 60 minus 15 is 45. 45 plus 9 is 54 root 6. And that guy's done. Then you come over here. Simplify, simplify, simplify. I want cube roots this time, though. So that's 27 times 4. That is 8 times 4. And that is 64 times 4. What's the cube root of 27? 3. So out comes a 3. 6 cube root 4. Plus, what's the cube root of 8? 2 cube root 4 plus cube root of 64 is a 4. 4 times 3 is 12. Cube root 4. What do you get to do because they're all the same? What do you get to do? Collect like terms. 6 plus 2 is 8. 8 plus 12 is 20. Cube root 4. And there I am done. Okay? All of that has been recorded. Take that onto this page and do page 103 tonight. And you have a quiz on exponents and simplifying radicals tomorrow.